Okay, let's continue on here. You notice that B, C, and D all have 3 numbers, but let's start first with A, which only has 2. And so we want to find the greatest common factor, and like the previous ones, you start with your 2 numbers that we're going to be looking at, and you want to bring them down to their prime factorization. All the prime numbers, which is what, 2 and 17? No, that can't be. Yeah, that's right. 20 and then 14 is 34. Wow, I think that's it. Okay, 85. Okay, well, if you don't know what that is, like right off the top of my head, I don't know what that is. So I'm going to put 5 into 85. 5 goes into 8 once. 1 times 5 is 5. 8 minus 5 is 3. Carry that down. 5 goes into 35 7 times, which gets me a remainder of 0. So that breaks down, 85 breaks down to 5 times 17. And sure enough, I have a 17 over there. Okay, so that works. So I'm going to just erase this here, but I'll give you a moment if you want to write that down. 34, I'll also list these out, and 85. 34 was 2 times 17, and 85 was 5 times 17. And we want to circle some pairs. Well, there's only a pair, and so the greatest common factor must be 17. Okay, so what about 3? Well, it's really not that much different. So there's 36, 54, 60. I like 60 because that's just going to be 6 and 10. And then that'll be 3 and 2. That should be 2 and 5. So, well, I'll finish up here. 54 is 9 times 6. 9 is 3 and 3. And 6 is 2 and 3. 36 is 6 times 6. And then both of those are going to be a 2 and a 3. So let's actually write this down in a row. It's easier for me to do when it's listed in a row. So 36 looks like there's a couple 2's and a couple 3's. So 2 2's and 2 3's. 54, there's 1 2 and then 3 3's. So 1 2 and then 3 3's. And then 60 is 2 2's and a 3 and a 5. So we're just going to be looking for what is common between all 3. So we're not looking for a pair, I guess we're looking for a triple. So I see a triple of 2's. Is there anything else? Triple of 3's. And that's the only triples. So I have a triple of 2's and a triple of 3's, which will get me 2 times 3, which is 6. So a little bit more work, just because it's an extra number, but not really anything different. Let's continue on here. 48, that's going to be 6 times 8, and as I said before, 8 I like to go as 2, 2, and 2, and 6 is 2 and 3. 30, well, that will be 3 and 10, and that 10 is a 2 and a 5, and I'll carry that 3 down. And 60 will actually be the same thing as 30, but then an additional 2. So it's a 6 and a 10, and then that will be a 2 and a 3, and then a 2 and a 5. So I should probably write these down in a row. 48. Now there's a lot of 2's here. So there's 1, 2, 3, 4. So there's 4 2's and then a 3. 30. There's 1 2, 1 3, and 1 5. 60 is there's 2 2's, a 3, and a 5. 2 2's, a 3, and a 5. So what do I got here? Triple 2's. Doesn't matter how you make it, by the way. I could do that, or I could do this. I'm just looking for triple 2's, and this one looked like a somewhat of a straight line. I can't do that with the 3's, however. I have to do this. Go boomerang or something. So a 2 and a 3. Oh, that's exactly the same as the previous question. 2 times 3, which gets us 6. Nice. There's nothing else. Okay. So let's go here. 60. Now, 60 I already did that. You can see it's right here. So I'm actually going to just kind of go right here to the 2, the 2, the 3, and the 5. So I'm not even going to make the tree because I know it's going to eventually lead to 2, 2, 3, 5. So that was easy. 96, however, I do have to do. So I can take that, and that's, what, 12 and 8? 12 is a 4 and a 3, and 8 is going to be 3 2s. 1, 2, 3. And that 4 is going to be a 2 and a 2. And then these can all carry down, the 3 and then the 3 2s. And 144, well, that's 12 times 12, which is 4 times 3 and 4 times 3, divided 6 and 2. So 2 and 2 carry down the 3, 2 and 3 carry down the 2. So I'm going to have to write this out. 60. Now 60 was 2 2s, a 3, and a 5. 96. Okay, so how many? There's a lot of 2s here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then a 3. And 144 is 1, 2, 3, 4. So there's 4 2s. 1, 2, 3, 4, and then 2 3s. So we're looking for, let's see, triples. There's a triple there, and there's a triple there. Are there any more? There's a 3. That's a weird triple, but there you go. And that shows me drawing it. And then the rest, there's some pairs, but there's only those triples. So there's a triple 2, a triple 2, and a triple 3, which would get us 2 times 2 is 4 times 3 is 12. So I'll zoom out here. That's GCF, and we will now work on some LCM stuff.